Okay, so we want to make a line of best fit, create an equation, and then predict using that line of best fit. Now, please note, this is really just scratch area for you to get your best interpretation of what you think this is, the line of best fit should be. So please note, that's what we're looking at when we do this. So I'm going to take this first dot, and I'm going to pick a number that I like on the y-intercept. So if I'm looking, I'm like, you know what? Obviously, it's not perfect, but I'm going to pick like 95 because why not? Then I'm going to go ahead and take this bottom line, and I want half my data to be above and half of my data to be below. So when I'm doing that, like, you know what? It looks pretty good at 90, so that's what I'm going to pick. So remember, when I want to make an equation, I need two things. When we have y equals mx plus b, I need my slope, which is m. My slope I see from my top line, I go down, and I go down 95, so that's negative 95, and I go to the right 90. So when I do that, I'm going to go negative 95 divided by 90, and it tells me to round it to the nearest hundredth. It does not want a fraction, it wants a decimal, so I'm going to go negative 1.06. Then my y-intercept, which I picked to be 95, so when I write out my equation, I go negative 1.06x plus 95. Now for this next part, it says that we want to figure out the heating cost for a month with an average temperature of 25 degrees Fahrenheit. That means I plug 25 into the equation. So I need negative 1.06 times 25 plus 95, which is 68.5. I can go ahead and I can check that. All right, doing that again. Again, this is just scratch area to get my best idea of what's going on. So in this case, I'm going to start at 10. And then if I look, maybe I don't want to start at 10. I'm going to start at 9 and then go like this, maybe. It's kind of hard. You can just kind of do your best. Maybe we'll go like that. Okay, so we're going to start at 10, and then we're going to go to 10. So when I'm looking at my slope, that means I went down 10 into the right 10, which is just negative 1. Then my y-intercept, which was 10. So I'm going to get the equation of negative 1x plus 10. Then it's asked me to predict the time spent exercising for a student who spends 5 hours texting. So I plug 5 in. When I do that, I get 5, which we can go ahead and check. Okay, doing this one last time. This time with it being the opposite direction. Again, I always start with my y-intercept. So I'm like, you know what? Let's start at 6 and see what we got. And again, I just like picking nice, easy whole numbers to guess off of. That looks good to me. So I'm going to start with my dot down here at 6, and I'm going to see that I went up to 28, meaning I went up 22. So when it comes to my slope, I go up 22, and then I go over 24. So it's 22 divided by 24, which when rounded to the second decimal place, or the hundredths, is 0.92. My y-intercept was 6, so when I'm writing my equation, I go 0.92 times x plus 6. Then for this last part, I'm going to plug 12 into my equation, so I go 0.92 times 12 plus 6, which gets me 17.04, which we can check. And that's how you can compute or approximate the equation of line of best fit.